Hello Middle One and welcome to a new video. In this video, I will tell you about the atoms and their constructions. So let's begin with the water. The water is formed of molecules. It's considered as a water molecule, and the molecule made up of the atoms. Look at the giant big picture of what is made of. The water as a compound is made of molecules, and the molecule made up of group of atoms as the smallest thing that can combine together. Okay, then now let's know a little more about the atom. As the atom is the smallest piece of matter, they made up of the atomic substances or the atomic particles, or the protons and electrons and nucleus. One more time, what does the matter consist of? The matter consists of molecules, and molecule consists of atoms. But first, what is the atom? An atom is a fundamental building unit of any matter, or it's the smallest part of any element that can be take part in the chemical reaction without it being changed. The particles of an atom. The particles consist of a nucleus that consists of two main kinds of protons and neutrons. And also we have the electrons that rotate around the nucleus in certain shells. This is atomic particles. Imagine with me the perfume particles are divided into tiny particles that can be seen by the naked eye or by the microscope. It needs a specific kind of equipment. These particles are spread and carried through the air in the room, having the perfume properties. This is a beautiful, nice smell for the perfume. These particles are called the molecules. So the molecules is the smallest particles of matter which can exist freely, and it has its own matter properties. I will give you an example for motion of the molecules inside the liquid state. We have permanganate salt, or it's actually potassium permanganate. Potassium permanganate is divided into particles and spread in water, gradually in all directions, until the color of the water has been changed into violet, giving a beautiful color. So if you put a little tiny potassium permanganate in the beaker or inside any bottle that consists of water, it will give you a beautiful color spread all over the water. And this is also the proof that the molecules in a state of motion or continuously state of motion. Okay, to sum it up, the properties of the molecules of matter. Molecules of the matter are in continuous motion. So matter, no matter what is in the continuous motion. There are intermolecular spaces or gaps between the molecules, and the molecules attracted together by a force that there are attraction force among the molecules of any matter. Then we have an example for the continuous motion of the matter, that we put a violet color or ink or potassium permanganate inside the water, and notice that the drop of permanganate continues and enter between the intermolecular spaces of the water. So it is spread out inside the water until we reach to the violet color of the water. Another example that shows that there is intermolecular spaces among the molecules of water. So we will prepare a graduated cylinder and pour some water. This is the reading for the water, and this is the reading for another graduated cylinder that inside it ethyl alcohol, and we mix the water and ethyl together, we note that we have 300 milli for the water and we have 200 for the ethyl. The sum of them, it should be 500. But we note that the summation of the 300 and 200, it become 400. It's less than the actually summation of the two in the normal case. So in the normal case, 300 plus 200 is 500 milliliter. But it will 400. That's because of the ethyl alcohol molecules enter between the molecules of the water. That proves that we have intermolecular spaces between the water molecules. Then we have a comparison between the solid and liquid and gas. We have the motion of the molecules. What about the motion of the molecules of the solid state of matter? The motion is limited in the solid state of matter molecules or between the molecules of solids. And in the liquids, it's little limited, but it can move. And the gases, it's relatively free. It moves very freely. The intermolecular spaces for the solid is very small. So the spaces or the gaps or the parts between the molecules of solids is very small. And the liquid molecules, it's relatively large. And the gases is very large intermolecular spaces between the molecules of gases. What about the force or the attraction force between the solids? It's very strong. And intermolecular force between the molecules of liquid is medium. And we have the intermolecular force of the gases is very weak. Okay, then we have the volume of the solid. The volume of the solid is definite. And the volume of the liquid is also definite, and the volume for the gases is indefinite. The shape is definite for the solids, and the shape indefinite for the liquid, and the shape is indefinite for the gases.